Hey there, kiddos. Hope everyone's doing well. Here's another problem that also uses linear ideas, or could use linear ideas. And we started today. I'd like to review it right now with you. And also, by doing so, review some line stuff. So, in any event, we saw this problem today. We know some information about the total tuition of Harvard in '89 and consequently in 2009, 20 years later. Okay, we're trying to predict, which sometimes mathematical functions allow us to do, what the total Harvard tuition would be in 2025. Okay, so the first thing I want to do is understand that I basically gave you two ordered pairs. 1989 is the year, and the corresponding total cost was as such, right? $19,995 for tuition. And then I gave you 20 years later, 2009, and the total cost, 48868, right? So we can think about these in terms of an ordered pair, right? Where we have year, and then cost, right? Cost being the total tuition, right? Maybe I should call it total tuition. Total tuition, and it's really room and board and everything else as well, right? Fees, etc., etc. Okay, so this also ends up being at least a discrete for now function where we have 2 points, right? The domain being 1989, 2009, and the range being the 1995 and a 48868, right? So it pairs the year with the tuition of that year with the tuition of that year, right? So I'm kind of thinking about this. Well, if we assume that the tuition rises in a linear fashion, now to rise linearly means it rises at a constant slope. So that brings up a fun word called slope. So let's go there. Let's do that. So between these 2 points, what is the slope, right? Well, slope is the change of the dependent variable, the change in total tuition, which would be 48868 minus 19995, right? So that's our change in quote-unquote y, right? But now we're talking about dollars, divided by the change in x, or the change in years in this case, right? So really it's 20, but what it would look like if we were to write it out is such, right? Change in y, the y variable, tuition, over change in x, time, year, right? And so if I do that out, 48868, 48868 minus 19995, right? I want to divide that by 20, which is the change in year, right? And I end up with this magical number, and it's dollars, $1,443.65 per year, right? My x is, my dollars, really, my y value is total tuition in dollars, my x value is years. Okay, so, well, what does this mean? Well, that means that for every additional year after 1989, assuming linearity, assuming that the slope is constant, assuming that the tuition rises at the same rate every year, or between any 2 years, or between any 2 moments in time, that the tuition will rise $1,443.65 per every 1 year, right? Okay, so we can use that to answer the question, right? Well, what about in 2025, right? And there are a lot of ways to do that, okay? One is we can kind of jump off, well, 2025 is how many steps after 2009? That's right, 16, right? So after 2009, I'm going to start with 48, the cost, right? That's a 2009 cost. And then we know that it's going to rise, the tuition, this much, 1,443.65 per year. Well, there are 16 years of rising from 2009 cost to the 2025 cost. So I have to add 16 of those 1,443.65s, right? Again, this being my slope, rate of tuition increase per year. There are 16 years that I have to jump off of 2009 to get the 2025. Right. And I don't know what that is. I'll use my calculator. 48868 plus 16 years times the slope per year, the rate of increase per year. 443 3.65, enter. Whoops, sorry. Don't need those commas. Enter. Okay, so I end up with 71,966.40, right? Okay. Now, this is our predicted, based on our linear assumption that the tuition will increase at a constant rate, the same rate as it has from 1989 to 2009, the same rate as it has from any 2 years, and it will continue to do so at the same linear rate. And that rate is this particular number, $1,443.65 per year. Okay? Now there's another way to do it. We can use our calculator. So let me just show you that. I'll go into Stat, and I'll go into Edit, and I'm going to put those 2 points in. I'm going to clear this junk. I don't want it there. And I'm going to clear this junk. Well, because I don't want it there. Really, all I want to do is I want to think of these 2 points. I want to plot them, and then I want to allow my calculator to get some numbers for me. So 1989 and then 2009 are the 2 x values of my 2 coordinates. And then the cost for those years is 19,995 and then 48868. Okay. Now what I want to do is I want to take a look at what that's going to look like. So I'm going to turn my plots on. We'll go over how to do this later. And then I'm going to make sure I got the right window. So I'm going to zoom static, just so I can see those 2 points in a window. That's appropriate, right? So here are my 2 points. Bam, 1998. This was the cost, right? So the x-axis is the year, the y-axis is the cost, right? And then my other point up here. Okay. Now what I can do is the calculator can tell me the equation of the line that rips through those 2 points. I could have done it by hand, but I'm going to use my calculator. So I want to let my calculator do some work for me right now. So I'm going to go Stat, Calculate, right? And what I want to do is calculate what's called the linear regression, the equation of the line between those 2 points. Right? And here it is. Okay? And so I'm going to write it down so I remember it. It's going to be y equals m, or a, 144365. Oh my gosh, that number looks familiar. Yep, that's our slope. We already got that number. And then plus, or really in this case minus, 2851424.85. Okay, now you may remember that that b term is the y-intercept. Okay, that's the quote-unquote starting point, but it doesn't make that much sense in this case. So I'm going to go through and I'm going to plug that function in my y equals. It's going to be 1443.65 x minus 28. I just remembered I wrote these down actually. 51424.85, and I'm going to graph that up. Oh, look at that line, it rips right through. Okay? Now, how can I use that line to help me? Well, now that I have that linear function, y equals m, my slope, 1443.65, minus, in this case, my b, my y-intercept, what I can do is I can ask my calculator, hey, in 2025, what will the tuition be? So really what I want to do is plug 2025 in for x, right? Now that's kind of a pain in the rear end, but I'm going to do it with my calculator. So I'm going to work through that process, and in order to do so, oh, it's already set up. Independent, which is the year I want to plug in, is already in ask mode. So I'm going to just go to the table, and I'm going to plug in. I want the calculator to tell me, hey, in 2025, according to this linear function, which runs through those 2 points, what will my predicted 2025 tuition be? Okay, so let's go back to the table. I plug in 2025. Oh my gosh, it already did it for me. 71,966, and it rounded it, right? Which is the same thing that we got. Okay, a lot of stuff out there, a lot of good math. All of it has to do with linear increase in this case, right? Constant change, and how we can use that to continue the rate at which, in this case, tuition is increasing constantly. Okay? Hope you enjoyed this. Let me know if you have questions.